morning students, welcome to Maths online class. Now today we do revision on areas of parallelograms and triangles chapter. Okay, so in that in the given figure, this figure ABCD is a parallelogram and AE is a perpendicular to DC and CF that is perpendicular to AD, and if AB is equal to 16 centimeter, AE is equal to 8 centimeter and CF is equal to 10 centimeter, find AD. Okay, you are given like that measurements, so I will write that measurements on the sides now. AB you are given that is 16 centimeter and AE this length AE length that is 8 centimeter and CF length that is 10 centimeter. So using that you have to find what is AD length, that is this length you have to find, AD length you have to find. Okay, so to find that you have to use area of a parallelogram formula. Area of a parallelogram formula you have like this. Area of a parallelogram that is equal to base into height. Okay, suppose you have a parallelogram like this and if you have a perpendicular, for example suppose ABCD is a parallelogram and AE is a perpendicular to DC, then this perpendicular lies on which side, that will be the base. Okay, DC will be the base and height is always perpendicular of that parallelogram. Sometimes base may be on the bottom or maybe on the side, left side or right side, or maybe on the top side. Okay, so suppose you have a parallelogram like this and perpendicular like this. ABCD is a parallelogram and if AE is the perpendicular on BC, then base is what? Base is BC. Okay, you have to keep in mind that that perpendicular is on which side, that side will be the base for that parallelogram, and height is what? Height is the perpendicular of the parallelogram. Okay, so that formula you have to use now to find the AD length. Okay, we have to use this formula 2 times. Now 2 times why we are using, because you are given 2 perpendiculars here, AE and CF. First I will use the AE perpendicular. Okay, so area of a parallelogram or area of ABCD that is equal to base into height. What is the base? See this perpendicular that is on which side? DC side. So DC will be the base. So base into height. Base into height that gives you what? What is the base? Base is the DC into height. Height is what? Height is AE. And what is the DC length? In a parallelogram you know that opposite sides are equal. So AB that is equal to 16 centimeter, opposite to that which side you have? You have DC. So that DC is also 16 centimeter. Okay, so that is not given in the question, but you have to know that opposite sides of a parallelogram are equal. So by that we can write DC is equal to 16 centimeter. So DC place we write 16 into AE that is given to you 8 and 16 into 8 that gives you how much? 8 into 6 48, 4 left, 8 into 1 8 plus 4 12, 128 and this is what? This is the area of ABCD. Okay, so area of ABCD we got 128 by using height and base like this, AE and DC. Now you take a height CF, one more perpendicular you are given, that is a CF. Now according to this perpendicular, what will be the area of a parallelogram ABCD? So now area of ABCD, area of ABCD that is equal to base into height, but area of ABCD we got here that is 128. So I will replace here by 128 that is equal to what is the base now? This perpendicular we are taking now, CF perpendicular, that is on which side? That will be the base AD. Okay, AD into base is AD into height. Height is a perpendicular, that is CF, and which length you are given? We have to find AD. So AD as it is and CF length you are given, that is 10 centimeter, and left side you have 128 and you keep only AD on the right side and send into 10 another side as by 10. Okay, so 128 dividing by 10 that gives you answer 12.8, okay, and all these measurements are in centimeter, so this is also in a centimeter, okay. So this is a AD length, okay. Next problem is if E, F, G and H are respectively the midpoints of the sides of a parallelogram ABCD, show that area of EFGH is equal to half into area of ABCD. First you have to draw one rough figure, proper figure you have to draw, then you will understand what to do next, okay. So now you have to draw one parallelogram, that is the ABCD. So draw one parallelogram and name that as ABCD, okay. Like this, take that as a ABCD, and next you see that E, F, G and H are respectively the midpoints of the sides of this parallelogram. So you mark the midpoints of each side. I will take first midpoint of first side as E, then midpoint of second side as F, then third side as G, and last one as H. And what you have to prove? Show that area of EFGH parallelogram you have to draw, because here you are given area of parallelogram EFGH, that is equal to half into area of ABCD. ABCD is there here, EFGH, that parallelogram is not there. So what you have to do is you have to draw parallelogram EFGH by joining EF, FG, GH and HE, okay. So with this much figure we can't prove that, so what you have to do is you have to draw diagonal, any one diagonal of this inside parallelogram EFGH. I will draw diagonal of inside parallelogram, this one, okay. We can draw HF also, any one, okay. And here you have to use the concept that suppose you have a triangle and a parallelogram which is on the same base, both are on the same base, and between a same parallels, then area of a triangle that is half the area of a parallelogram. This one you have to use now, okay. So here can you see like that situation, triangle and parallelogram which are on the same base and between same parallels. See now here you have a parallelogram, that is AEGD. In that parallelogram, can you see this triangle, that is a HEG triangle, and this parallelogram AEGD, that parallelogram that are on the same base GE and they are between same parallels. So what we can write using that area of a triangle HGE, that is equal to half the area of which parallelogram, this one AEGD, okay. So AEGD, and take this as a equation 1, and same type you have to write a sentence, okay. Since triangle HGE and AGED parallelograms are on the same base and between same parallels, we have like this, okay. Same type you can see in other part of the figure also, okay. There what you have triangle GEF, that and parallelogram GEBC, they are on the same base GE and they are between same parallels. So what we can write according to that area of this triangle, that is half the area of this parallelogram, okay. So we write that here area of GEF, that is equal to half the area of its parallelogram GEBC, okay. GEBC, and you take this as equation 2, and after that you add equation 1 and equation 2. So adding 1 and 2, what we get? Equation 1 plus equation 2, left side plus left side, that is area of triangle no need to write, area of HGE, that is equal to half into area of AEGD in the first one, you have to add 1 and 2, left plus left. So left side what you have in equation 2, that you have to write area of GEF and is equal to right side plus right side. So that gives you what half the area of AEGD plus the right side of equation 2, that is this one. Okay, half into area of GEBC. And you see this one on the figure. What it gives, I shaded that HGE means this triangle and GEF means that triangle. If you take that two triangles together, what it gives, that you can see in this figure, that is the shaded part. Okay, that shaded part gives you what? Gives you EFGH parallelogram. So left side by observing the figure, that much is what? Underlined 1, that is area of EFGH, and that is equal to, here you can see half is common, you take that half out, so then what are the remainings that you write inside the bracket? So then you get area of AEGD plus area of GEBC. Okay, and that is equal to half into, what is this from the figure? You observe AEGD. AEGD means this parallelogram. Okay, this parallelogram, and next what you have plus area of GEBC. GEBC means this parallelogram. Together that gives you, plus means together that gives you what? Bigger one, that is ABCD parallelogram. So that together by observing the figure, you can write that as area of ABCD. What you have on the left side? Area of AFGH. Okay, so we proved this one, area of EFGH is equal to half the area of ABCD parallelogram. Okay, for this you have to use the area of triangle is half of the area of a parallelogram if triangle and parallelogram are on the same base and between same parallels. We used that 2 times, and we got like this equation 1 and equation 2, then we added, then we observed the figure and we got this one. Okay, thank you.